For the extra practice, I want to just go through a couple more examples just to make sure we really understand how to solve these problems. For this problem, our first step is we need to draw our line down our equal sign, and we find our variable, which is e, and ask ourselves, what is the farthest away from e, but still on the same side? And it looks like it's this 4 right here. And this is adding 4. The opposite of adding 4 is subtracting 4 from both sides. This is equal to 0. So I'm going to get 4 times e is equal to 8, because 12 minus 4 is equal to 8. Now I ask myself once again, what is the 4 and the e doing to each other? In this case, they are multiplying. So we are going to divide both sides by 4. 4 divided by 4 is 1. So I get 1e equals 2. And because the e is alone, or there's only one e, I should be done, and I'm ready to check my answer. I'm going to take this number 2 and substitute it in for this value of e above. So I get 4 times 2 plus 4 is equal to 12. 4 times 2 is 8. 8 plus 4 is equal to 12. Is a true statement, therefore, my answer must be correct. Let's do another. This problem looks very similar to what we've been doing. Once again, I need to ask myself, what number is on the same side as my variable, but the farthest away? In this case, it is 18. So I'm going to subtract 18 from both sides. Not like that, though. There we go. This is equal to 0, and I get 7y is equal to negative 28. Once again, what's on the same side as y? This time it's 7, so I'm going to divide both sides by 7, and I get 1y is equal to negative 4. Last step is always checking my answer. So I'm going to do 7 times negative 4 plus 18, and I'm hoping this is equal to negative 10 when I'm done. 7 times negative 4 is negative 28, plus 18 is equal to negative 10, and that is true. That gives me negative 10 is equal to negative 10, and so I'm done. Let's do one final problem. So what I have here is negative 2x minus 13 equals negative 6. But I want to do something a little bit different. I'm going to take this negative 6 and I'm going to move it to the left side. So the equation is still the same, but it's going to feel just a little bit different because now the variable is on the right side instead of the left. Once again, though, we're still trying to get the variable alone, so I'm going to add 13 to both sides of my equation. So even though it looks different, the process is still the same. Now, the problem I have here is I'm going to divide both sides by negative 2, and that's going to give me 1x equals negative 7 halves, which is the decimal negative 3 5/10. And immediately some of us are going to think when we get decimal answers that, oh no, I made a mistake. But that is not the case. You can get decimal answers. If you remember the TV problem from the last video, that was a decimal answer, and that's totally fine. In fact, most real-world problems are going to be decimal answers. We can still check our decimal answer just like anything else to make sure it works. So we have negative 6 equals negative 2 times negative 3 1/2 is going to be positive 7 because negative times a negative is a positive. Positive 7 minus 13 is negative 6, which does equal negative 6. We get a true statement, and therefore our answer is still correct. So we can get decimals, we can get fractions, but the real takeaway from this video I'm hoping is that even though we are not going to solve equations like this in the real world, doesn't mean we're not doing algebra in the real world. As always, if you have any questions, please let me know.